Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Mewa Virtual Remedial Classes 2025. And in this table of contents, there is two things that we'll be talking about today. And these two things are all part of one larger thing called motion caused by gravity. So there are two situations. Una a body that is projected upwards, and there's a body which is falling downwards. So that is projected upwards ni body aina yote kama tutakavyoona hapa. Let me yeah, let me just select this. Yeah, that kind of motion whereby kitu kimetoka chini kimerushwa kwenda juu. Let me use a bit of Kiswahili. Kitu kimetoka chini kimerushwa kwa juu. Kwa mfano umechukua jiwe then umeirusha kwenda juu. Sasa ukaiacha iende mpaka juu huko kabisa. That is what is known as a body projected upwards. And in this kind of motion, as you can see here, there are two different things. U is usually known as U is what is known as initial velocity. Initial velocity. Initial velocity. U, which is known as initial velocity, is at maximum in this case, kwa sababu ukianza kuirusha ile kitu, ukianza kurusha ile kitu, what happens is that let me repeat this. Ona, ukianza kurusha ile kitu, you una there's some kind of force that you apply to that body. That's why ina move kutoka chini kwenda juu. Sasa, and one thing we want to remember is that the reason why V is equals to 0, the reason why V is equals to 0, it is because the motion of this body is against gravity. This body is acting against gravity. Kumbuka, gravity is acting in a downwards way. That is gravity. But this body is moving upwards. So the velocity, the initial velocity is higher than the final velocity. Just erase something here. Yeah, the initial velocity is higher than the final velocity since this thing has a negative g as its acceleration. Acceleration yake ni negative. Now, as we said in the last lesson, when something acceleration when something has a negative acceleration, ama acceleration yake ikipungua, that means that thing is slowing down. It is not going faster, it is going slower. Or in other words, it is decelerating. Sasa, there are three formulas that are used in this kind of situation. The first formula, which the general formula was V is equals to U plus AT changes. And I can show you briefly how it changes. So, the formula is V is equals to U plus AT. AT. This is the general formula. But remember, in this kind of a situation, V is 0. So this whole formula will be 0 is equals to U, and remember that A is negative G. The acceleration in this case is negative G. Since this thing acts against gravity, yani inapingana na gravity. Gravity makes things to fall down, but this thing is going up. Sasa, so since it is acting against gravity, inapingana na gravity, that means V, which is 0, will be equals to U minus GT. minus gt. That is how this formula ends up. So ukiipeleka hii gt minus gt to the other side, that means it will be u is equals to gt. That will be the final formula. That means if you have the initial velocity na uko na acceleration due to gravity, you can get the time. For example, if you have a bullet, let's say, that is shot upwards at 300 at an initial velocity of 300 meters per second, and you want to get the time taken for the bullet to move upwards until it reaches maximum height. So what happens is that 300 will be equal to g, which is usually 10 meters per second squared, times time. So if you divide 10 on both sides, divide by 10, and here also divide by 10, we'll get that if you divide by 10, 300 divided by 10 will be 30. So the time taken for the bullet to reach maximum height is t. Yeah. So that is all. 30 seconds. The initial velocity of the bullet was 300 meters per second. That is one formula, how we use it. U is equals to g t. Provided you have initial velocity, you can get the time taken for the motion to be completed, or the time taken for ile kitu kutoka chini mpaka ifike maximum height, from downwards to upwards. All that time taken for that upward motion can be found using the initial velocity. So this formula can be used, I'm sorry to go back, is that for example, in a situation, there are many situations where this formula can be used, but basically we were told that a body, let's say we had this body over here, it was projected upwards at a height of let's say at a height of 20 meters, 20 meters, and the time taken for that body to move from downwards to upwards was let's say 10 seconds. The time taken for this body to move from downwards to upwards was 10 seconds. So what will be the, let me think. Oh, let me rephrase this question. Let me just rephrase this question a bit. So a body, let me rephrase it. A body took 10 seconds to move a height of 20 meters. Yeah. A body took 10 seconds to move a height of 20 meters upwards. So provided that g is constant, g is always in all situations, g is 10 meters per 10 meters per second square. That is the constant formula of g, and g is the acceleration due to gravity. So what was the initial velocity experienced by this object? So 20 meters, which is the height covered by this body, is equals to ut 10 u, basically, because the time taken for this motion was 10 seconds. So it is 10u minus a half minus a half g, which is 10, a half times 10 times t squared times 10 squared. So a half times 10 times 10 squared is basically 500, because 10 times 10 squared is 100, times 10 is 1000, times a half is 500. So 20 is equals to 10 u 10u minus 500 minus 500. So this 500, my negative 500, we should take it to the other side. So if we take it to the other side, it will be 520. 520 is equals to 10u. 10u. So divide both sides by 10, divide by 10, and divide by 10. So u will be equals to 52. 52 meters per second, which is a high speed, because 52 meters per second, if we convert it to kilometers per hour, is 180 kilometers per hour. So that was the initial velocity of the body. So the third formula says that v squared is equals to u squared plus 2as. That's the general formula of linear motion. In this kind of motion, turns to u squared is equals to 2gh, and I can show you how it turns to that other formula. So remember, in this case, v is 0. V is 0. So since v is 0, this one will all turn to 0. So it will be 0 is equals to u squared minus, because remember, a is equals to in this the acceleration is negative g. So this thing is decelerating from downwards going to upward. It is slowing down. Decelerating is another word for slowing down. So u squared minus 2gh, hii kitu ina slow down. So kwa vile ina slow down, the acceleration will be, acceleration yake itakuwa negative. So but we cannot just leave it like this. We'll have to take all this negative 2g na tuipeleke to the other side, tuipeleke to the right side. So tukiipeleka to the other side, itakuwa u squared is equals to 2gh. Hiyo ndo itakuwa yeah, that will be u squared is equals to 2gh. That means if we want to find maximum velocity, I mean not maximum velocity, maximum height, it is as simple as saying h is equals to u squared over 2g. So actually there is no need to use the second formula when you are calculating for maximum height. As long as you have the initial velocity, uko na ile initial velocity by which the body was projected upwards, hapo unapata maximum height. For example, if we refer to our past example where u was equals to 300, the bullet example, 300 meters per second. That means if we take 300 squared, it will be equals to 90,000 if I'm not wrong. 300, but you can use your calculators to just confirm. 300 squares is equals to 90,000. Yeah, u was 300 u was 300. So if we take u squared, it will be equals to 90,000. So the heights taken in this, the heights which will be covered in this case will be equals to u squared, which is 90,000 divided by 2g, 2 times 10, or 20 in this case, 20. So divide by zeros on both sides. 9,000 divided by 2 is 4,500. So the heights which will be covered in this case is 4,500 by the body. So you can see how linear motion becomes very very simple with this modified formulas. Hizi formulas ambazo zimebadilika. Na hizi formulas zimebadilika because of some things becoming zero. So they become more simpler. Yeah. So let's start in this motion. The first formula in this motion is V is equals to GT, and I can show you briefly how it is formed. So if U is 0, V remains to be AT. V remains to be AT. But you remember in this case, the acceleration is equals to gravity. And this is because the body is the motion of the body is caused by gravity. As you can remember in Form 1 physics, gravity makes things to fall down. So this body falls down from an upward height because of gravity. So since velocity is equals to, since A is equals to G, it remains to be final velocity is equals to gravity times time. So that is the first formula. The second, S is equals to ut plus a half at squared becomes h is equals to a half gt squared. So let's say, let me draw something here. This body moved from this position at a specific height. Let's say the height was 20 meters. Ulipanda mpaka juu ya building ukaachilia kama ni kitabu from at a height of 20 meters, and you want to know the time taken for that book to fall from up to down. Yeah, that's just a curiosity most of us had. Kwa mfano niko na kitabu, nataka kujua hii kitabu nikiachilia from juu kwenda mpaka chini, how many seconds will it take before it hits the ground? So the simplest way to calculate this is simply taking that height. Let's say the height is 20 meters. So 20 will be equals to, remember here initial velocity is 0. So hii ut yote inakuwa 0. Since ut inakuwa 0, inabakia a half at squared. But remember a is equals to g. So hii g inakuja ina replace a hapa. Inakuja ina replace a hapa, so inakuwa a half gt squared. So a half times, kumbuka tulisema the acceleration caused by gravity, and I want you to never forget this, that the acceleration caused by gravity is always 10. So a half times 10 times t squared. A half times 10 times t squared. So a half times 10 ni 5. A half times 10 ni 5. So 5 times t squared is equals to 20. 20 meters. So divide by 5, and the other side also divide by 5. So divide by 5, divide by 5, here it becomes t squared. Now 20 divided by 5 is equals to 4. So t squared is equals to 4. If you want to get what is t, we'll square root both side. So t will become 2 seconds. So basically, that is the time taken for the book to fall at a height of 20 meters. If I can repeat, the reason why height becomes a half gt squared is because u is 0. So since u is 0, s will become, and since u is 0 and a is equals to g, a is equals to g, s becomes a half gt squared. That is what s becomes. And the third formula of this motion is v squared is equals to u squared plus 2as, which is transformed. And it is transformed because remember, u is equals to 0. So since u is equals to 0, v squared becomes 2gh. Yeah. V squared becomes 2gh. And here, remember, s is height. The displacement covered by the motion is the height of the object, the initial height of the object when it was there upwards. That is the displacement covered by the motion. So that means if you have the height of the object, you can get the final velocity, which will be covered by the final velocity of the body when it hits the ground. So for example, and we get it by simply transferring 2g to the other side. Na ukiipeleka hii 2g to the other side, inakuwa v squared divide by 2g. V squared divided by 2g. So for example, there is an object which is falling from 100 meters. Yeah, an object falling from 100 meters. So 100 will be equals to v squared, which is unknown, divided by 20. So we want to know what will be the final velocity of this object. So we cross multiply. Tukicross multiply, v squared inakuwa 20 times 100, which is 2000. Yeah, that's what happens when we cross multiply. So the square root of v squared will be v, and the square root of 2000 will be the value of the velocity. If I just use a calculator, wait a minute. Square root of 2000 is simply 44.72. 44.72 meters per second. Yeah, that is the final velocity of the object as it hits the